Okay, so in the last video, we looked at example 3 for solving trig equations using identities and factoring as the strategy. And you want to take a second, pause the video, and try this problem on your own if you didn't yet, and then come back and go over the solution with us. For those that already did, let's go ahead and work through this example together, and you can check your work. So here we've got a trig equation with both sines and cosines in it. So we're going to start by doing a Pythagorean identity, since these are squared here, so that we can get the same function rather than two different trig functions. And if you recall on the Trig Identity Hexagon, you can remember your Pythagorean identities because they form these triangles that I've just shaded in. For example, tangent squared x plus 1 is equal to secant squared x. 1 plus cotangent squared x is equal to cosecant squared x. Or the one that we're going to use, sine squared x plus cosine squared x is equal to 1. So we'll just jot that down here. Sine squared x plus cosine squared x is equal to 1. That's our Pythagorean identity. And we have sine squared x here, and if I solve this Pythagorean identity for sine squared x, I would need to subtract that cosine squared x to the other side. So I would have 1 minus cosine squared x that I can substitute now in place of sine squared x in the equation. So doing that substitution, I then have 1 minus cosine squared x is equal to 3 cosine squared x. Okay, now I want to try to get everything on the same side of the equation so I can combine like terms. So I'm going to go ahead and add cosine squared x to both sides. And now I have 1 equals 3. Oh, whoops, not 3. Let me fix that. 1 equals 4, because I've got 3 already. So 1 equals 4 cosine squared x. And since we're doing the factoring method, I'm going to go ahead and move over this 1 as well, because before you can factor, your equation has to be equal to 0. So now we have 0 equals 4 cosine squared x minus 1. And we recognize that as a difference of squares. So it would factor as 2 cosine x plus 1 and 2 cosine of x minus 1. And using the zero product property, once it's factored, we would set each factor equal to 0 and solve for x. So in this first side, 2 cosine x plus 1 equals 0, we're going to subtract the 1, divide by 2, and cosine of x is equal to negative 1/2. To get the x by itself, we need to do the inverse function for both sides, and x is equal then to the arc cosine, or the cosine inverse, of negative 1/2. And we want to look on the unit circle for all the places where the cosine is a negative 1/2. In quadrant 1, we can see that at pi over 3, the coordinate is a positive 1/2, but there are no negative x values in quadrant 1. If we remember the acronym all students take calculus, A stands for all of the trig functions, all 6 positive in quadrant 1. S is reminding us that the sine and its reciprocal cosecant are positive in quadrant 2. Tangent and its reciprocal cotangent are positive in quadrant 3. And in quadrant 4, cosine and its reciprocal secant are positive So since we want the places where the cosine is negative, that answer cannot come from quadrants 1 or 4 because cosine is positive in those two quadrants. So the answers where the cosine is negative, those are in quadrants 2 and 3. So we're going to need this angle for quadrant 2 and this angle for quadrant 3, knowing that the reference angle of the same size was pi over 3, right? Because pi over 3 had that 1/2 as its x-coordinate in quadrant 1. So if the whole circle is 2 pi, half that would be 1 pi, which is 3 pi over 3. So I would go backwards from there. Since I'm moving in the clockwise direction to get into quadrant 2, I would subtract pi over 3. So 3 pi over 3 minus pi over 3 is 2 pi over 3 as our first answer. And then going forward in the counterclockwise direction means I need to add. So I would start at 3 pi over 3 and add pi over 3 to get a 4 pi over 3 answer from quadrant 3. So my two solutions for this first factor set equal to 0 are 2 pi over 3 and 4 pi over 3. Okay. Now for the second factor, we add 1 to both sides and divide by 2, and cosine of x is positive 1/2. Again, we do the inverse of cosine on both sides, and x is equal to the arc cosine of positive 1/2. So looking on our unit circle for where x is a positive 1/2, we already found one of those answers here at pi over 3. And our other answer is going to come from quadrant 4 because that's where cosine is also positive. So if a whole lap around the circle is 2 pi, that would be 6 pi over 3 along the positive x-axis. And we went from 0 in the counterclockwise direction to get to positive pi over 3. Now to get from 6 pi over 3 back in the clockwise direction, we're subtracting. So 6 pi over 3 minus pi over 3 gets an answer of 5 pi over 3. So our last solution is 5 pi over 3. Okay, then we want to check these answers in the calculator. So we're going to go to the mode and make sure we're in radian mode, which we are. And then we'll store 2 pi over 3 as x and type in our original equation here just as it's shown. Remember, there's no notation in the graphing calculator in the TI-84 plus for that square, the sine squared of x. So we're going to recall that that's the same as taking the function sine of x and squaring it. Okay, then we want to do second math to get to the test menu. Number 1 up here is our equal sign, and we want that to equal 3. And then again, we're going to do the cosine of x and then square that function, since that's the meaning of this notation, cosine squared of x. Okay, when we press enter and we're using an equal sign in the calculator from the test menu, we're actually asking the calculator a question. We want it to tell us whether or not this checks. So when we substitute in 2 pi over 3 for all those values of x in the original equation, if it checks, the calculator will say yes with a number 1. If it doesn't check, the calculator will respond 0 for no. So we press enter and it checks with a 1, so 2 pi over 3 is a solution. Next, we're going to test our answer of 4 pi over 3 by storing that in the calculator as x. We'll arrow up to the equation and press enter so we don't have to retype it, and enter again, and we get a 1, which means 4 pi over 3 also checks. Then for The next solution, we want to look at pi over 3. So we'll store that as x. Arrow up to grab that equation. Press enter, and pi over 3 checks. And then last but not least, 5 pi over 3. Store that as x. Grab that equation one last time. Press enter, and 5 pi over 3 also checks as a solution.